About two types of lenses. We have converging lenses. So if you're wearing glasses right now, you're wearing one of these lenses. The lens is actually converging lenses. We have few shapes of them. The most common one looks like this. It's called a converging lens because what happens if you watch the beams going through it, the one in the middle goes directly in the middle. We'll talk about how do we graph them in a second. But the reason they call that a converging lens, because as the light hits that, they converge to a point. It bends in. That's called a converging lens. All the lights converge in. If you're a far-sighted person, that means the picture is forming behind where it's supposed to. We need to bring it closer. We use that type of a lens. Now, if you go to the doctor, sometimes they use lenses like this. Sometimes they make the lens look like this. They're all converging lenses. Like thin layer like this. Sometimes it looks like one end almost straight and the other end looks like this. All these are converging lenses. But this is the most common picture that you see in the physics book. The other type is called diverging lenses. That's for nearsighted people. And the lens is a glass. There is no block, so mirror one side is painted black so the light doesn't go through it. Lens is glass, so the light will go through either end of it. So the most common picture for diverging lenses looks like this. That's the most common you see in physics book. So when you graph that, the reason they call them diverged lenses, when the light hits that, instead of meeting this way, they bounce like this. So they never meet, they diverge, they go away. Another common picture for diverging lenses, they look like this. One side straight, the other one is not. The other one you might see looking like this. Like one side skinnier, wider on the outside, skinnier on the inside. But all these are called diverging lenses. I might have a better picture on the book here for converging versus diverging. This is a converging lens. This is a diverging lens. They do a better job than me. Converging, diverging. And again, the reason they call them converging lenses, notice what happened to the lens here. We shine a light at them, they all meet. Can you see the lights all meeting at a point there? Brought them closer. This one pushed them away, diverged them. That's a diverging lens, that's a converging. We have a few of them in the lab upstairs. Yeah. If we get a chance on Tuesday, we'll go and play with them. You know, just shine a light on them and watch them go through. Again, a different picture, different book. It looks something like this. That's probably a nicer picture to see. You can see the beam of light. All of them converge to one point. That's a converging lens. Pushing them away, that's diverging lens. So if you want to graph and see where the image is going to form, we're going to do the same thing we did before. We're going to create three rays, the P ray, the F ray, and the M ray instead of the C ray. We'll call it M. So let me write the type of rays here. I'll go through actually an example while I'm doing it. Where's my graph paper? Right here. Let me take graph paper. This one. And let me put my lens here. I mean my axes here. And we'll do the same thing. Maybe we'll do some scenario. If it's closer, farther, what's going to happen? And let me put my lens. Now I'm going to make my lens. That's a converging lens. Notice it takes a thickness to it. So what we do with these, we draw a line, straight line up and down, and we use that for our graph as if it's our lens. So I'm going to use that line as my lens. This line right there. Now where the actual lens is. Since it's identical, let's put a focal point. Last time I used 5, I'll change it this time. 1, 2, 3, 4, 5, 6. Just to be different. 1, 2, 3, 4, 5, 6. Right there. That's the focal point for each one, each side. Doesn't matter which side you use, identical usually, especially for that lens. Now let me put an object somewhere here. I'll put it far away even. There's my object. More than twice that value. So I used last time color coding. The first one was P ray. P for parallel. That's why we call the P ray. Parallel ray. So it's parallel to the axes. Then what happens? Once it goes, this actually does go through the lens. Bless you. The P ray is going to get bent. Is bent so that it passes through the focal point. The focal point will only pass through the focal point that's of a converging lens. Sometimes they call the converging lenses by the convex lens. This is a convex lens, which means converging. So here's what's going to happen. The P ray is going to go through the focal point right there till it hits that line up and down. That's the P ray. And it's going to pass through or bent going through the focal point. It's going to bend going through the focal point. Bent in that direction. That's the P ray. The F ray. Again, they call the F ray for focal point. That's why it's called the F ray. It's drawn through the focal point and continue and keep going onto the lens. So draw it through the focal point and continue going to the lens. Let's see what will happen. Through the focal point, continue going to the lens. This is the P ray. Now it's going to, F ray, I'm sorry, not P ray. That's the F ray. Now it's going to bend. Now the lens will bend the ray. I'll just say bends the ray instead of will bend. It will do it anyway. Bends the ray. And it comes out parallel, so that it is parallel with the axes. So when it hits that, it's going to come out parallel with the axes. Let's draw a parallel with the axes. It's going to bend it this way. And the third one, the M ray, M for middle, I'm sure, or midpoint. That's why it's called the middle. Goes through the middle of the lens. Middle of the lens. So going through the middle of the lens, this is the middle of the lens right here. It's going to go through it. And here's the good news. What happens once you go to the middle lens? It continues. It doesn't bend. Ongoing, straight. So it continues just like nothing happened. The one through the middle never bent. And where the three of them meet, that's where your image is. So my image here, you can see from this picture, is going to be upside down. Can you see it? That's where the image is. What you notice about the image is inverted. What else you notice? In this case, it looks like what? Reduced. That's not always the case. And what about the side? Other side. You're going to find out here that other side is different here than with mirror. Other side means you have a real image. If the image shows up on the opposite side, that's a real image. If it shows up on the same side, it's a virtual image. It's backward to mirror. Mirrors were backward. In mirror, if the image shows up on this side was a real image, on that side was virtual, here is backward. It's on the other side, that's a real image. What happens if I put the object actually before F? I put outside F. I'll do another case where it's before F, between F and the lens. Let's see what will happen there. Then I'll do a diverging one, then we'll go to the equation. I'm just going to make my lens just straight line going up and down. I'll just put a little thing in it. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my focal point. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say I put the object right here. Color coding, the P ray is the blue. P is parallel. Okay. So let's do the P parallel. Is going to, again, hits this one, is going to bend going through the focal point. That's the P ray. The M, I already grabbed the black color, so I'll go with the M since I already grabbed it. Going through the middle of that and never bends. I can tell you, based on these two lines, they'll never meet on this end. They will never meet. They're going away from each other. That's the M ray. We have one more. What color was that, the other one? The red one. And that's the F ray. Going through the focal point. It's going to look like it's coming from here. And the one through the focal point, we said it comes out what? Parallel? And they're supposed to meet to form that image. And it doesn't look like they're going to meet on this end. Maybe they're going to meet on that end. So we're going to extend all the lines, all the reflected lines, and see what will happen. We'll use a pencil for that. So let's extend. Okay. Let's extend all these, the reflected beams. Take this one, stretch it. If I'm using a pencil here, if I stretch it, it goes up all the way up there. Let's take the blue one. That's, which one's the blue one? What do we call it? What was the color blue? Blue is the P. Now my writing is over it now. This is the F ray. Because I wrote P early. P is the parallel one, blue. Let's extend the P ray. And let's extend the F ray, the red one. And where do you notice the beam meets? All three of them. The same spot right here, right? Can you see it? So that's my image now. That's the image. And if I look at my image, what do I notice about it? The image here, characteristic, let's see what we have. We have upright. It looks like it's what? Enlarged. And it's the same side as the object. In this case, because the same size object, that's virtual image. So if you place the object between F and the lens, you're going to have an image that's bigger in the upright virtual image. If you place it to the left, we just did that, your image is going to be what? Inverted, reduced, real image. That's when you're dealing with convex or converging lenses. What happens when you deal with diverging lens? It's only one case, diverging lens. With diverging lens, we only have one case, just like when we did convex mirror. P is the blue, F is the red, M is the black. Just to remember that. Okay. Let's look at diverging lenses. Again, my lens, here we go, it's diverging, so this is a diverging. I'm just drawing it right now like this. One, two, three, four, five, six, seven, eight. F. 1, 2, 3, 4, 5, 6, 7, 8, F. It really doesn't matter where you put the object. You can put anywhere you anywhere you want to. So I'm going to put my object right here. So only one scenario for that. Again, blue is the P ray, the parallel. And it's going to go away, deflect from it. It's still going to go through the lens. It's the glass going to go through it. So it's not going to bounce back like with mirror. With mirror, we had it going back because it doesn't go through it. This one continued to go through, but it's going away. So the only way to be going away if you make it like this. It looks like it's coming from here. See it? That's the direction it's going to go. The M ray, that's going through the middle. And the one through the middle never deflects. It just keeps on going. And the last one is the F ray, the red one. F is going through the focal point. Now, when you say going through the focal point, it's going, not this focal point, going through that focal point. So it's pointing in that direction, going through that focal point. Notice I'm pointing toward that focal point. But once we hit that edge, that's the F ray, once we hit that, it's going to come out parallel. And you can see now, again, they will not meet on this side. Not going to meet on this side. So then where are they going to meet? Let's extend all three lines. If you extend the three lines, well, the M ray is fine, but let's look at the red one and extend that. And let's look at the blue one, extend that. and the three of them meet right here. So that's where my image is. So for diverging lenses, the image is always going to be a virtual image because on the same side. It's always upright and it's always reduced. Always. Now, just like mirrors, a lot of people don't want to do these by hand. They just want to use the equation. So let me use the equation. Excuse me. Let me use the equation and just calculate this stuff, and that's where I'm going with it actually. The last piece, and I'm done. Instead of graphing them, how do we do this mathematically?